Motions of Earth. Before we start the chapter, let's recall what you have learned in the previous chapters. Our solar system contains 8 planets and Earth is one of the 8 planets of this system. Sun is our star and all the planets, including our Earth, revolve around the Sun. All the planets also rotate at their axes. Thus, we can say Earth has 2 types of motions. It revolves around the Sun and rotates on its own axis. The equator divides it into 2 halves, that is, Northern Hemisphere and Southern Hemisphere. You have also learnt about different heat and time zones. But have you ever thought the reason behind these heat zones and time zones? How days and nights are formed? Why the seasons change? All this happens because of motions of the Earth. Motions of Earth. There are 2 types of motions of Earth, that is rotation and revolution. The Earth revolves around the Sun. The speed of the Earth in its journey around the Sun is nearly 120,000 kilometers per hour. It completes 1 revolution in 1 year, that is 365 days and 6 hours. This annual motion is called revolution. While revolving around the Sun, it also rotates on its axis. Do you know what is axis? Axis is an imaginary straight line joining the 2 poles on which the Earth rotates. The axis of Earth is not straight. It is tilted at an angle of 23.5 degrees from a perpendicular to the orbital plane. Thus, the axis of the Earth makes an angle of 66.5 degrees with the plane of Earth's orbit. This tilt of the axis is called the inclination of the Earth's axis. The Earth rotates from west to east and completes 1 rotation in 24 hours. Rotation, revolution, and the tilt of the Earth's axis are responsible for many events, like formation of days and nights, change of seasons, etc. Let's discuss their effects one by one. Rotation. Rotation is the turning around of the Earth on its axis from west to east. Rotation causes all parts of Earth's surface except the poles to move in a circle around the Earth's axis. The rotation of the Earth results in 3 major effects: east-west movement of Sun, formation of day and night, and circulation of air and water. You have seen that the Sun rises in the east and sets in the west. During the day, the Sun appears to be moving from east to west. In fact, it is not the Sun that moves, it is the Earth that moves. You won't believe because you never feel this movement of the Earth. Let's understand it with the help of an example. You must have traveled in a train. While looking out of the window of the train, you might have seen that the trees and houses seem to be running backwards. In fact, it is not the trees and houses that are moving, but it is the train which is moving. Similarly, as the Earth moves, the stationary Sun appears to be moving in the opposite direction. The Earth moves on its axis from west to east. That is why the Sun appears to be moving from east to west. This is known as apparent movement of the Sun. The most important effect of earthly rotation is formation of day and night. The Sun is the source of heat and light for the Earth. The Sun gives light to only half of the Earth at a given time, When the Earth rotates, only that half of the Earth which is facing the Sun is in light, and the other half away from the Sun is in the dark. Thus, each part of the Earth's surface comes in front of the Sun for some duration, and then it passes into the dark every 24 hours. The half of the Earth which is in light has the day, and the other half has night. Let us understand the movement of Earth and systems of day and night by doing a simple activity. Take a globe and a lighted lamp. Place the lamp at some distance from the globe. Now assume that the globe is the Earth and lighted lamp is Sun. Mark a point P on the globe to represent your town. Place the globe in such a way that the point P is in the dark. We know that Earth rotates from west to east. So we will rotate the globe from left to right. That is, west to east, and notice the change. The point P will slowly turn towards the light of the lamp and reach a position where it receives some diffused light. Turn the globe further and point P will have the light. Now the rays of light from the lamp will start reaching the point P. On rotating the globe further, we can see that the rays of the light from the lamp at point P become vertical. Now turn the globe further. Point P is moving from light. A slight rotation of the globe will show that the point P is getting only diffused light. Still more rotation of the globe will carry the point P just away from the lamp of light, and it will be in complete dark side. Now let us see the same in the context of Earth. When point P was in dark, it means that portion of the Earth is in dark side and has night. Then we rotated the globe towards light and point P was getting diffused light. It means now your town is having the dawn, just before the sunrise. Then we rotated the globe further and the point P was having the light, so now it is sunrise in your town. On rotating further, the point P reached at the point where light rays fall vertically on the globe. It means the sun is overhead. Can you tell what is the time of the day at this point? Yes, it is noon, when your town will get maximum light. On moving further, when the point P is about to move away from the light, you will reach the sunset. And when point P is getting only diffuse light, it means this is dusk, after the sunset. Again rotating the point P reached in complete dark. It means now there is again night. It will be the midnight time at point P. Now if we mark another point O opposite to the point P and repeat the activity, we will see that when P is in light, point O will be in complete darkness. Which means when there is a day at point P, point O will have night. Similarly, when point O is having sunrise, point P will be experiencing dusk. Thus, by this activity, we see that different points on the Earth will have morning, midday, evening, and midnight at the same time. Third effect of rotation of the Earth is circulation of air and water. The Earth's rotation causes a consistent change in the direction of the flow of winds and water of the oceans. Throughout the year, we experience changing seasons. The warm spring brings new flowers. This season is followed by a hot summer with high temperature, hot winds and monsoon showers. Following summer, there is another warm season known as autumn, where leaves turn beautiful shades of reds and browns before falling off their trees. Finally, after all of these warmer season, comes one that is cold, wet and dry, known as winter. What causes the changes that we see throughout the year? Why is the winter cold and the summer hot? All this is result of revolution of the earth. The movement of the earth around the sun is called the revolution. Earth revolves around the sun at a fixed path known as orbit of the earth. The earth completes one revolution in 365 days and 6 hours. For our convenience, we consider the year as consisting of only 365 days and ignore the 6 hours. This time of 6 hours is added up to 1 day after every 4 years, and the 4th year is called a leap year. In the leap year, the additional day is added in the month of February. The year 2008 was a leap year. Can you tell which leap year will follow 2008? It will be 2012. The revolution of the earth results in changes in seasons. But actually, the cycle of seasons is the combined effect of revolution of the earth and the tilt of its axis. The axis of the earth is tilting at an angle of 66.5 degrees. Thus, the axis of the earth in its orbit around the sun remains tilted to one side. Due to this inclination in one direction, the northern hemisphere remains inclined towards the sun during 6 months every year. Thus, a larger part of the northern hemisphere faces the sun during this period. Every point in this part of the earth remains lighted for a longer time. Hence, the days in this part are longer. Opposite to it, the southern hemisphere is away from the sun. Therefore, the days in the southern hemisphere are shorter. During the following 6 months, the southern hemisphere is inclined towards the sun. Then the days in this hemisphere are longer. At this time, the northern hemisphere has shorter days. If we talk about Arctic and Antarctic Circle, then due to this inclination, these experience 6 months days and 6 months night. When the northern hemisphere is inclined towards the sun, the Arctic Circle remains continuously in light and therefore has day for all 24 hours and no night. On the other hand, the Antarctic Circle around the South Pole remains continuously in the dark. Thus, the South Pole will have night all the 24 hours and no day at all. When the southern hemisphere is inclined towards the sun, the South Pole will have continuous day and the North Pole at this time will have continuous night. Due to this, the North and the South Poles and Arctic and Antarctic circles have 6-month-long days followed by 6-month-long nights. The days and nights are equal at the equator. However, as one moves away from the equator towards the poles, the difference between days and nights increases. The difference increases so much that the poles experience 6-month-long day. This long day is compensated by an equally long night also. This is the result of inclination of the axis of the earth. Had the axis of the earth not been inclined, the days and nights would have been equal throughout the world. Thus, revolution also affect duration of day and night. The changing seasons. There are 4 seasons in a year: summer, autumn, winter and spring. All these seasons have different temperature and climatic conditions. Two main factors responsible for seasons are the Earth's revolution around the Sun in elliptical path and the tilted surface of the Earth. The phenomenon of changing seasons can be understood with the help of four positions of the Earth during its revolution around the Sun: summer solstice, winter solstice, summer equinox, and autumn equinox. Just recall your experience when you go close to fire. How do you feel? You feel warm or hot, but as you move away from it, you feel cool. Same thing happens with our Earth. The Sun is a ball of gases which releases heat. During revolution, the Earth receives heat from various angles at different positions. Like if the sun rays fall on a place by making an angle of 90 degrees, that place will receive maximum heat. As the Earth revolves around the Sun, it comes at different positions. Moreover, due to elliptical orbit, it is never on the same distance from the Sun. Sometimes the distance between the Earth and the Sun is as minimum as 147 million kilometers. Then it is said to be in perihelion. And sometimes this distance is maximum at 152 million kilometers. It is said to be in aphelion. Thus, with change in its position and distance, season also changes. Broadly, we see there are four positions: spring equinox, summer solstice, autumn equinox, and winter solstice. Spring equinox. On March 21st, the overhead sun is at the equator. The equator receives the largest amount of solar radiations. Both the North Pole and the South Pole are neither inclined towards the sun nor away from it. So both hemispheres receive equal amount of light and heat. All the places have equal days and nights. It is spring in the northern hemisphere and autumn in the southern hemisphere. The angle of the sun decreases towards the poles. After this, it is spring in the northern hemisphere when the days are longer than the nights. In the southern hemisphere, it is autumn when the days are shorter than nights. On 21st June, due to the tilt of 23.5 degrees, North Pole is inclined towards the sun and the South Pole goes away from it. The overhead sun is over the Tropic of Cancer, so the rays of the sun fall vertically at the Tropic of Cancer because of the North Pole is tilted towards the sun. Therefore, the part of the Earth which receive more light and heat will have long day and hot weather. Hence, the northern hemisphere has the longer day and shorter night. On the other hand, the southern hemisphere, which is farther from the sun, will have shorter day and longer nights. This position is known as summer solstice. This day is the longest day in the northern hemisphere and shortest day in the southern hemisphere. Besides, there is 24 hours of daylight in the Arctic and 24 hours of darkness in the Antarctic Circle. The Earth continues revolving and the amount of heat varies day by day according to its position. On September 23rd, it again comes to a position when both the North Pole and the South Pole are neither inclined towards the sun or away from it. The overhead sun is at the equator, so both hemispheres receive equal amount of light and heat. All places have equal days and nights. At this time, it is autumn in the northern hemisphere and spring in the southern hemisphere. This position is known as autumn equinox. After this, it is autumn in the northern hemisphere when the days are longer than the nights. In the southern hemisphere, it is spring, when the days are shorter than the nights. As it revolves further, the North Pole moves away from the Sun and the South Pole comes closer due to the tilt. And on 22nd December, the South Pole is inclined towards the Sun and the North Pole is away from it. The overhead Sun is on the Tropic of Capricorn, so the days are shorter and nights are longer in the Northern Hemisphere. And the opposite to it, the days are longer and the nights are shorter in the Southern Hemisphere. It is summer in the Southern Hemisphere and winter in Northern Hemisphere. This day is the shortest day in the Northern Hemisphere and the longest in the Southern Hemisphere. This position is known as winter solstice. Besides, the Arctic Circle has 24 hours of darkness and the Antarctic Circle has 24 hours of daylight. From spring equinox to autumn equinox, the North Pole is completely in light. So the Arctic Circle has all days for 6 months and the South Pole, which is in dark, has all nights for 6 months. Contrary to it, in the next 6 months, that is during autumn equinox to spring equinox, South Pole remains completely in light and North Pole in complete dark. Thus, Antarctic Circle has days and Arctic Circle has nights for 6 months.